Hi guys, Lokesh here from SQL for All. So welcome to chapter 2 of this video tutorial series. In the video 1, I explained why it is necessary to learn SQL and what are the benefits associated with learning SQL. I especially touched on the career and the salary aspect of it. So I believe you have watched the video 1. If you haven't watched the video 1, I'll share the link and you can watch the video 1 right here. So before we dive into any coding part, we need to understand some of the basic concepts. These basic concepts are like the building blocks. If you understand these basic concepts, I'm sure that you'll be able to learn SQL and grasp the knowledge in a much better way. So I think most of us might have worked on an Excel sheet or Excel spreadsheet. This is one of the most widely used tools in any industry. So the tables that we have inside SQL, or you can say small entities which store data that we have inside SQL, are also very similar to the Excel spreadsheet. In fact, the idea of these tables was derived from spreadsheets and other documents which store information. So like Excel sheet consists of rows and columns, the SQL tables also consist of rows and columns. And in an Excel workbook, there are many spreadsheets or many worksheets. So we can imagine that each of the worksheet as a single table in a database. So the database will be a collection of all these Excel spreadsheets. So just keep these simple things in mind that we are comparing a table with a worksheet and the rows and columns of the worksheet with the rows and columns of a table, and a database may consist of several tables, that is several spreadsheets, or may consist of a single table, that is a single spreadsheet. So moving on, some of the examples of database. So what is database? This question might be coming in your mind. So database is anything that stores information. It can be a systematic information, it can be unsystematic information, it can be an organized information, it can be unorganized information. So all these examples are of database. A report card, a passbook, a personal diary, these all are databases. So anything which has some information or a data is called a database. So another important question that we need to address here is the difference between a data and an information. Data consists of raw numbers, figures that does not make any sense until and unless you add some dimensions on top of it. For example, in the current scenario, what we have done is we have added the days and the price against the figures you see on the left side. So this means that the trend in the stock price for the last 10 days. So if you organize data into this fashion, it conveys some information. We can easily see the trend for the last 10 days, and therefore it adds context to your data. So this means that you can store data in any format into a database, but that data will not necessarily make any sense until and unless you provide some transformation on top of that data. And how do we provide the transformation? We use SQL for that. So as I told you, information is nothing but when we give the context and meaning to a data. There are some more differences between data and information that you can see over here. You can just make a note of it. The basic difference is data in itself will not make any sense, whereas the information will give you what is going on or what is happening with the data. So now let's discuss about DBMS and RDBMS. DBMS stands for Database Management System and RDBMS stands for Relational Database Management System. So as the name implies, this is a management system which is used to take care of the data that is stored into a database. There are certain rules that one needs to follow in order to maintain an RDBMS or a DBMS. The basic difference between a DBMS and RDBMS is that the tables inside a DBMS do not have any relationship between them, whereas in RDBMS, the tables do have some relationship between them. Let's take an example to discuss this. So in our DBMS, we have a single table called employee that stores the employee ID, employee name, department ID, department name, all in a single table. Why we are doing it? Because we don't have any facility for maintaining relationship between tables. Whereas on the other hand, you have a relational database management system that consists of two tables called employee and a department. You can store all the information of employees into a single table, and then you can store the information about the department into another table. And you can join or you can combine the information between these two tables with the help of a common column called employee ID. So this concept of breaking down the data into smaller chunks is called normalization. I would encourage you to search about it or read about it in the from the internet, or you can borrow any book. Uh, in that you can learn about the various ways of normalizing. There are various standards of normalizing, and I would also encourage you to read Codd's rule for RDBMS. Codd was a scientist who discovered the RDBMS, and he designed certain rules. So if you want to design a relational database management system, you ought to follow these rules. If you don't follow these rules, then your database will not be classified as an RDBMS. So moving on, I want to shed some light on SQL and SQL Server. I think most of the times the SQL term SQL is used very loosely. And so we have SQL and a SQL Server. A SQL is just a language. Let's understand what the front end and the back end is. And if you happen to be a SQL developer or a SQL admin, then where do you fit in this picture? So front end is all the websites that you use in order for booking tickets, may it be railway tickets, flight tickets. So front end is the fancy websites that you see at your end, whereas you must be wondering from where all this information on the website comes. And for example, if you book a ticket, where does the information get stored? Well, that gets stored into a database. So it's a two-way process. What I'm showing you here is the process when the website fetches information from the database, and your role would be to maintain the integrity of the data that is being pulled from the database, so that it is not corrupt, it is up to date. So yeah, so this is how it looks like. You have a front end and a back end, and the data flows in and out, and your job is to make sure that the data is flowing smoothly and as per the expectations of the front end applications. Now there are two varieties of SQL. We have PL SQL and we have T SQL. In order to understand this, you need to understand that there are two types of databases that are majorly used across all the industries. We have an Oracle database, and then we have a SQL Server database. Now, the PL SQL is just a language to pull the data from an Oracle database, and T SQL is the language that we use in order to pull the data from a SQL Server database. How do these languages differ? They they don't differ much in terms of the syntax, but yes, there are some pros and cons of each of these languages. We will be studying mostly T SQL in this case because we will be fetching data from SQL Server, and we will be concerned about storing data into a SQL Server that is owned by Microsoft.